Hello and welcome to this week's I2I broadcast. And today I want to talk about the 5 Platonic solids. So let's shoot right over to the presentation. What are the 5 Platonic solids? How are they related to each other, and how are they related to the 5 elements? This is the topic today. And these are the shapes. Yeah, you can see it right now. As kind of like a framework. We're going to go more into the 3D world, but most of us are probably familiar with the cube, which is the one in the center over here. But all of the other ones, they all play a very, very important role. And Plato is an ancient Greek philosopher, and he says the knowledge of which geometry aims is the knowledge of the eternal. Yeah, which means by understanding geometry, we start to understand more about the nature of reality and the nature of our own being. And so the Platonic solids obviously have their name from him because he started to study them. But the truth is, they're actually much older than that. So there are some discoveries that were made in Aberdeen, Scotland, from the Neolithic era, so many thousands of years ago, and there are definitely similarities to the five Platonic solids. Obviously, there are people who argue that, but you can just have a look and see for yourself. I feel like they look very much like them. So it's quite interesting that these shapes always come up, and it seems like they seem to play a very, very big role in understanding 3D space. So let's have a look at what kind of solids we're talking about actually. So we have 5, and they have different kinds of complexities. In general, you could say each of them has the same characteristic as every single corner has exactly the same distance to the center, so that's why they can all fit inside of a sphere. And at the same time, every single point has the same distance to every other point, yeah, on the outside. So the faces will always be the same, and that's why they're also called regular polyhedra, because they're regular and they're in perfect symmetry and perfect equilibriums. We have 5, and one you're probably most familiar with is the cube. Sometimes it's also called hexahedron, and it has 6 faces. They're all square, and they have 8 vertices. Vertex is basically a corner, so from the corner to the center it has 8 vertices. And then we have the octahedron, which is, in a sense, you could see, it's almost like the opposite of the cube, because it has 8 faces, yeah? So this has 8 vertices, well, it has 8 faces, and it has 6 vertices. And because it's 8 faces, it's also called octa. Yeah, that's why it has the name. And then we have the tetrahedron. For most people, yeah, this is considered to be the smallest because it's the first time 3D space can come into existence. Because if you take one corner away, then obviously it makes a triangle, which, by the way, is the smallest 2D shape. So the tetrahedron is considered the smallest with 4 corners. And what's the unique part of this one is it has 4 vertices and also 4 faces, and it also has a tip. Yeah, it's a bit different than the other ones. Then we have the dodecahedron, and this one consists out of pentagons. Obviously, you can see it, and it has 20 vertices and 12 faces, while the icosahedron has exactly the opposite again, 12 vertices, so 12 points here, and 20 faces, and they consist out of triangles. And that's quite amazing because we actually only have 3 shapes in total in 2D, the triangle, the square, and the pentagon, who make 3D space. And what's cool about these shapes is the fact that actually there are only 5. You cannot make any other shape with the same characteristics. There is no 17-sided hexahedron. Yeah, so it doesn't work. We only have 5, and I think that's why there has been a lot of mysteries about these shapes, why they're actually only 5. And as I want to talk today also about the 5 elements, there is kind of like this correlation. So where is this 5 actually coming from? And if we're thinking about reality and it's made out of this geometric architecture and the basis are these 5 shapes, then maybe we should look into them and what are really their qualities. And it's really amazing that it's just 5, because let's say if you have 2D and you have a circle, you can place actually an infinite-sided, well, the circle is infinite-sided, but like, let's say a 10,000-sided shape, you can place it in the circle, but in 3D, you can't do that. You only have 5, and that's why it is quite a mystery. So what are the properties of these Platonic solids? And on the one hand, it's quite interesting, this octahedron, you see it actually has these triangle faces, but you can also see that when you look at it from the side, it actually has squares inside as well. And it actually has three square forms in it. It's like two pyramids on top of each other. Yeah, like the pyramids of Giza, they have a square bottom. And this is in a sense also for the octahedron. So we have the triangle and the square coming together. And what's amazing about that is because in 2D, and if you think about 2D tessellations, so let's say you want to fill space, yeah, in 2D. Normally we think about a square because like a chessboard, yeah, you can just tessellate it into infinity. The other regular shape who can do that is the triangle, and that's actually it. There are only two main shapes that tessellate in 2D, which is the triangle and the square. We also have the hexagon, but obviously the hexagon again is built from triangles. So the fundamental 2D shapes is the triangle and the square, and they're both found in the octahedron. And that's an interesting point when we think about 2D space makes 3D space. Yeah, so that's just a side note here. Then we have the tetrahedron, yeah, with 4 faces. And it's quite interesting because the tetrahedron is the only one that has a tip on the top. Yeah, I mean, I can even put this flat on the table and they would all be flat if I lay them down flat. But the tetrahedron is the only one who's got a polarity in a sense. And the unique feature of that is you can actually put 2 together, yeah, and they compound, and this is then called a star tetrahedron. So you have a different kind of property here. We'll talk a little bit more about the shape in a second. Then we have the cube. Obviously, we all know about the cube. This is what we normally learn in school as being 3D space. And the unique feature of the cube is it kind of makes 3D space, like Tetris. Now you can make a lot of cubes and put them together, and you can fill space without having any gaps. You cannot do this with the other shapes by themselves. So this is a unique feature of the cube, and that's why it's called a space-filling polyhedra. Then we have the dodecahedron, which is the only one with pentagonal sides, faces. And the pentagon is quite an interesting one because you can make a 5-pointed star in here, and you can continue making 5-pointed stars. So it's kind of like you have this fractalized pattern in the pentagon. And what's really cool is that actually this shape, the pentagon, does code the golden ratio, phi, which is this really, really famous divine proportion that you can find in your body. Leonardo da Vinci was working with it. If you study art, you probably know about this number. It's kind of like a divine proportion that we find everywhere in nature. And this is the shape that actually has it within itself already, yeah? So, and then we have the icosahedron, and the unique feature of the icosahedron is that you can actually take it apart into 3 pieces, like you can see here, and then it can rotate. And that's why we often say, actually, icosahedron, in a sense, is like the male version of the torus. So if you have followed my broadcast before and you realize that you have a dot and then there's a circle and it makes a torus like a donut shape, and that's like, you know, the electromagnetic fields throughout the universe, that's the shape of electromagnetic fields, like the Earth, then the icosahedron is the shape that actually could represent it as a kind of function and property. So it's quite interesting that all of these shapes have a certain function, and let's see how they're related to each other. And it's quite interesting that, as I said already in the beginning, certain solids have, it's like almost like opposites, yeah? They have opposite features. Like the octahedron has 8 faces, while the cube has 8 vertices. So when you put them together like this, you can actually place them inside of each other, like Russian dolls, yeah? So you can put the octahedron inside of the cube, and it will perfectly define the center of the face of each cube. Yeah, so 6 corners of the octahedron go to the 6 faces of the cube. while the 8 corners of the cube can also touch the 8 faces of the octahedron. So they're duals of each other. Like you can place them inside of each other, and they kind of relate to each other like this. And the same thing goes for the dodecahedron and the icosahedron. So you can place the dodecahedron inside of the icosahedron because it touches the center of each face, and vice versa. So 12 corners to 12 faces and 20 corners to 20 faces. And that's already quite interesting to think about, okay, how do these shapes then come into existence? Yeah, they have to have some sort of relationship. And there's now the tetrahedron, and the tetrahedron has a very unique feature because it's a dual of itself. I haven't shown you this picture here, but as already mentioned, it can compound with itself. And this is important when we want to understand how it can also nest with the other solids, except that it nests within itself. So when we put 2 tetrahedra together, it creates the star tetrahedron. What's amazing, actually, we can make the star tetrahedron from the octahedron itself. So if we could place small tetrahedra on every corner of the octahedron, kind of like an extension, or let's imagine there's a dot inside of the octahedron and it expands out, boom, in 8 directions, it actually would create the star tetrahedron, yeah, which again is 2 tetrahedra inside of each other. And notice that it's actually representing a cube, because if you could just connect all the corners together, it will make a cube. So the octahedron works together with the tetrahedron or star tetrahedron to make a cube, and here we can already see a pattern. What does it mean? It means that these solids can nest in a very particular way. And obviously, if you look on the internet, there's many other suggestions on how they can be nested. Very often you find actually the very similar pattern like this, but just with the icosahedron as the smallest one. And we decided to do it in this way, and I'll tell you in a second why it makes more sense, at least for us. Yeah. So we start actually with the octahedron. So the octahedron is the smallest. The octahedron can be placed inside of a tetrahedron. Obviously, this can be a star tetrahedron. Yeah. This tetrahedron or star tetrahedron then makes the corners of the cube. The cube can nest inside the dodecahedron, and it does so by this golden ratio. Yeah. So actually, the length of the square side length is actually the golden ratio if this is 1. And then the whole dodecahedron can, the dodecahedron can then fit inside the icosahedron, and the icosahedron is basically the all-encompassing form. So why is that? Why did we think about it like this? And what does it have to do with the 5 elements? So if you're thinking about elements, yeah, today we think about elements, we think about the periodic table. This is not what I mean. What I'm talking about more is the classical interpretation of the 5 elements. So the ancient Greeks in Tibet, in China, in ancient India, they were all talking about reality, that it consists out of indivisible units. I mean, maybe they were thinking about atoms, but in terms of characteristics, there were only 5 elements that we can experience. So let's say we can experience fire, we can experience water, we can experience air, and something that is solid, earth, and then we can experience the ether. And there are obviously different ideas about the ether, and we would say it's probably something like electricity. Yeah, and this is quite interesting. Today we don't consider them to be 5 elements anymore, because when we think about the atomic structure, actually, yeah, they look very different. But in terms of matter, you can still kind of categorize it in this way. Yeah, you have liquid, solid, and gas, and then you have, in a sense, fire and electricity. It's kind of, what some people maybe would categorize in plasma. So there we go. We have the 5 elements, and now we're just going to look at nature. Yeah, so how do elements actually come into existence? What's the order of elements? And if you study universal geometry, you notice that actually there are repeating patterns everywhere in nature. So if you find something on the atomic level, it can reflect as well on the larger scales, or it can reflect around the body. So actually, by observing nature, we can apply the same kind of phenomena to the very basic structure. And one example here is the Earth. So think about the Earth. The Earth in the center has, well, at least at some point, it has magma, it has fire, yeah, it has kind of a the fire center. And if the volcanic activity, the lava comes out and it hits the water, then the water and the fire kind of cool it down and they make the earth. So in a sense, and that's a metaphorical, metaphysical map, right? You have the fire that interacts with the water to make the earth. So fire, water, and earth. And then above the earth, yeah, we're here and we're living above the earth and we're breathing air, yeah? So then we have air. And then from the air, we're going out to the outer layers of the atmosphere, and you could say the whole Earth is wrapped in an electromagnetic field. So the ether, in a sense, would then be the last of the elements. And this is, in a sense, quite, yeah, it's a nice story that really fits well with this nested set, where we say, okay, we got the octahedron, which is the first one that stands for fire, and that's why we also color-code it like this. Yeah, the octahedron you will always see is going to be red. Yeah, so this is fire. Then water would equate to the tetrahedron, and that's also quite interesting if you think about the molecule water. It's actually H2O fits inside the tetrahedron. It has a triangle formation, but it can fit inside of a tetrahedron. Then the Earth, as most would agree, and also Plato would agree, is the cube, and above that we have the dodecahedron, and then the icosahedron being the last one. And what's interesting about this nested set is that these three solids, so the tetrahedron, the cube, and the dodecahedron, they actually fit inside the exact same sphere. Yeah, exactly the same sphere, while the octahedron is in a smaller sphere and the icosahedron is in the bigger sphere. And that's quite interesting in terms of also our interaction with reality, because we can interact with water, liquid, solid, and gas. Yeah, we have no problem interacting with these things. Yet when it comes to fire, we get burned. And when it comes to electricity, we get a shock. So this is just another thing that you can notice about this pattern and how it reflects then in the elements and how we perceive them. So for us, it's kind of a very nice model that seems to at least explain some of the ideas in this metaphysical world. But at the same time, if you think about what shape comes first, and I talked about this last time, it's actually the octahedron. Most people believe in sacred geometry. They believe that everything comes out of this flower of life pattern, the seed of life pattern, and I showed you already how it can actually pop into 3D by these three axes. Yeah, they can pop into 3D and they can make the first solid, which is the octahedron. And not only that, because even in the atom, and I'm going to go much more detail about the atomic geometry, even in the atom, yeah, after the first spheres, the octahedron is the very, very first form that comes into existence, which is a noble gas. Yeah, so we're talking here about neon. And all of the other solids, actually don't see all of them, but some of them, they come later. So that's why we believe it kind of makes sense. And this is very different to the models that are currently, yeah, that people believe in, or mostly we believe in this model, which is, yeah, actually is based on Plato. And he said that they're related to the 5 elements. And back in the day, he was actually, because the tetrahedron is the smallest, he would consider it to be fire. And in the sense, because of the flame, it's like that. But they didn't know about atoms back in the day. And the icosahedron then would be water. And yeah, and the octahedron would be air. And the dodecahedron would be ether. And also that has to do because the dodecahedron was very long. They couldn't find out about this shape. It was the last shape to be discovered, so I guess that's why they figured it must be the ether. But if we think about really, the icosahedron is really the only shape of the 5 Platonic solids that shows this rotation. And if you're thinking about ether, or let's say electricity and electromagnetic fields, it's always changing. Yeah, it's a 4D shape in a sense, and something is rotating. So the icosahedron on that level could at least represent that rotation, because you can put it into 3 parts and it can rotate. And not only that, we also know about the Earth and the energy centers of the Earth, sometimes called ley lines, these energy centers, and they actually follow also this pattern of the icosahedron. So obviously, it's always an abstraction, because we cannot really point it down. Oh, this is earth, this is fire, this is water, because in a sense, this is not how the atomic structure looks like. But what this model gives us is kind of like an understanding that there must be some sort of foundation of reality. And this foundation, the limitation of 5, just reflects in so many different levels. And the 5 elements is just one part of that. But see, even we only experience reality through 5 senses. So, and then there's these 5 notes in the musical octave, the black notes. And so there are many kind of limitations that need to come from somewhere. Yeah, it's not like infinite. There is some sort of laws, and it's quite interesting that you can find some of those correlations to geometry, and maybe that's why also the ancient cultures were thinking about space in a sense. What are the indivisible units of space in terms of regularity? And so we've been basing a lot of our ideas on this model, with the octahedron being the first, and just see how actually they are nested, how they relate to each other, and how they then develop and can predict phenomena of the atom, or even in chemistry and in biology. So hopefully we can explore more about the nature of reality through geometry. So what did we learn today? Yeah, we learned about the 5 Platonic solids, that they're basically the most fundamental 3D forms because each of them are in perfect equilibrium, and they are the only ones that fit inside of spheres in perfect harmony. And if you think about 3D space, then something like this is probably the foundation of it. And actually in science, everybody always talks about the cube. It's at least one of them already, but there are 4 more forms. We saw how they are actually related to each other, that you can nest them inside of each other, and we've done it in a different way to a lot of other people. So we started with the octahedron because for us it just makes more sense, because it's the first one that comes into existence from the seed of life. When you rotate, everything is through rotation into 3D, makes the octahedron. It's the first form that exists in the atom, so it kind of makes sense. It's the first one. And when you follow the pattern of nesting, then the octahedron is the first, the tetrahedron is the second, the cube, the dodecahedron, and then the icosahedron. And that reflects very perfectly with how elements not come into existence, but how they express themselves in reality. For example, in the earth, you have the hot magma inside, then you have the water layer, and the water and the fire make the earth, in a sense. It's a metaphorical story. And then above you have the air, and then outside you have the electromagnetic field. And that fits also very nicely with the properties of these solids. Octahedron being the only one with tetrahedrons and squares, which is the foundation of 2D space, and the icosahedron being the one that can rotate, which looks like an electromagnetic field, doesn't it? So I hope you learned something here, and just to see that we're approaching this whole subject a little bit different than the traditional model. And it seems like doing so makes more sense when it comes actually to the world of matter. What I'm saying is not that the other nested forms don't exist. They probably do, because creation is infinite and there's probably all possibilities exist. But in terms of our reality and looking at matter, it kind of makes sense to think about it in this way. Yeah, I hope you enjoyed this quick broadcast about the Platonic solids. We actually wrote a book about this. It's a very small pocket book that you can put in your pocket, in your trousers, and where you can actually build a nested set, just like the one that I showed you, from just cardboard and paper and a drawing compass, and you can actually make it yourself. And we have a little bit of knowledge in there, what it means and the properties. So if you would like to get your hands on and learning, like having this learning experience, then yeah, it's in the link. You can check it out. Other than that, I see you tomorrow, and I wish you a great day.